Hi guys, and welcome to the second video in the Chemical Monitoring and Management series for HSC Chemistry. This one's about the need for collaboration. Why is it that we even talk about this as an area that you need to learn as part of your senior chemistry course? Well, I guess there's a couple of reasons for that, but probably most importantly is that in the last video, we looked at the fact that there are many different chemical specializations, lots of different branches of chemistry, and each of them comes with a particular specialization. And as a consequence of that, chemists often know a very large amount about a very small area. Their knowledge of the breadth of chemistry is usually pretty good, but about one area it's very deep. And that's very difficult for anyone to be able to retain at a large enough level to encompass all of the different work that's being done in chemistry. So what happens is these different branches lead to chemical specializations. And not only is that the case, but often chemists, like most other scientists, will be working in cooperative teams. So groups that have particular tasks associated or assigned to them that they need to complete, and that there are, and they may or may not actually be located in the same physical area. And we'll look at an example where that was not the case later in this video. But that are going to need to maintain some level of communication and consistency if they're going to make progress together. Chemical problems are often complex. They may have breadth, they may also have depth, and they may also be trying to solve very new sorts of questions. And as a consequence of that, there really is scope for a diversity of input. Lots of different chemists throwing ideas around, discussing them, talking about what they understand, what their work is revealing, and other chemists who want to actually read about that, see if there's anything that's applicable for their own work. Most chemists don't work in isolation, and those that do would still be reading papers from other chemists to try and get a sense of what's going on. And of course, even if they were working in isolation, often their work can affect other chemists, and other chemists' work can also affect theirs. So there needs to be some levels of communication, collaboration in order for that to occur. But the benefits of collaboration are significant. And these are kind of the ones that are really what this is all about. And that is, first of all, collaboration results in clarity of communication. It's much easier. Most scientists are reasonably good communicators. They have a bit of a stereotype lab coat wearing nerds. But most scientists have got, like yourselves, good command of English, particular strength in some of the jargon associated with chemistry. And as you're already aware, not only is there jargon, there's also contractions of words such as redox, a contraction of reduction oxidation, which chemists understand and which non-chemists or lay people often don't. So you're already starting to build up a jargon of chemistry to understand not only what questions mean, but how to answer those. And this is very important when chemists are collaborating with one another, that they understand and consistently use words in the same way, and that increases the level of clarity there is between them. In order to, I guess, further develop that, there is an international system for chemistry known as the IUPAC system. We've talked about this before, and it's related to things like nomenclature of organic compounds, of carbon compounds. So when we've been looking at how we name our different functional groups and the different homologous series, that comes from the IUPAC system. That is a consistent way of naming things for chemists all around the world. Nomenclature is also important for inorganic salts, substances that are combined often as a result of acid and base reactions, and again need to be named in a consistent way. But it's also useful for things like units, making sure that units are consistent. We know that there are differences even in things like kilometers and miles, or litres and gallons in different parts of the world, and so therefore we need to make sure that units are consistent. And of course, one of the most important units in chemistry is the mole. And so it means we've got a standard that, upon which we can rest all of our research, all of our work, and with which we can effectively communicate to people who are doing similar or at least related work around the world. Now, there's one there's lots and lots of examples of collaboration, of course, but one interesting example worth having a look at is a couple of Nobel Prize winners from 2000 in the category of chemistry. And they were Alan Hegar, Alan McDermid, and Hideki Shirakawa. And these three scientists all lived in different countries, in different hemispheres, no physical proximity to one another, and not necessarily even a common language, certainly not a common first language, and yet were able to collaborate not only effectively to actually progress their work, but to develop something completely new in the area of conductive polymers. So this is an example, a cover from one of the chemistry magazines of conductive polymer. And the way that these three gentlemen set about working together, collaborating in order to share their ideas and their understandings about how charges may be carried and transmitted through different layers in polymers. You can see hydrogen ions and electrons being the charge carriers. Hydrogen ions obviously have protons. And this resulted in a Nobel Prize being awarded to the three of them in equal shares as a result of their ability to collaborate effectively with one another and to through that collaboration to progress each other's work to the point where they were able to achieve something that they may not have been able to do at least as easily alone. So just another example of how collaboration assists chemists in order to help them achieve their goals. Unfortunately, in this video, there's no end question. I always like to end with a question, related question from HSC papers. But what you'll find is for the first two videos, one looking at branches of chemistry in a particular case study, and this one on collaboration, there's very little that ever comes up in relation to questions associated with these areas. What that means is that the concept is very important and underpins a lot of what we do in chemistry, and particularly in this topic when we're looking at how chemists work together, how they analyze different components of our environment, how they bring that data together and interpret that data, and how they may report on that data to other chemists and also to lay people who perhaps don't have the same strength in their chemistry backgrounds. So don't expect too many questions on collaboration, but do understand that it's part of everything that happens in chemistry. It's the reason why we want you to learn how to name structures correctly, to observe consistencies in terms of units, and also in terms of things like significant figures when you're doing your calculations. Thanks for watching.